There she is, Natalie Haymaker, and that's her navigator with her. And there they are in real life, off on another adventure. Except that, hey, where's your navigator?
He's been kidnapped by bad guys. His mother is really worried. He could be anywhere in the world. How am I going to find him?
That is a problem.
He left a message, but it doesn't make sense to me. Help. They're taking me to 30 degrees west longitude on the equator. I wish he had left a message I could understand and use.
In order for a message to be useful for locating something, it needs to give measurements from two starting places or lines. These lines are sometimes called axes. Even on a ball, like the Earth, you need two axes to locate a point. And long ago, people decided where the two axes would be. One axis is this, the equator.
That's a line running east and west around the Earth exactly halfway between the two poles. I knew that.
That's right. And from that starting place, you can measure distances north and south. The north-south distance of any place from the equator is its latitude. The other axis is this, a north-south line called the prime meridian running between the north and south poles. The prime meridian could have been placed anywhere on the Earth.
It could?
Yes. People agreed to place it here because in this position it runs through Greenwich, England, where there was a famous observatory. With the prime meridian as a starting place, you can measure distances east and west on the Earth. And when you do that, you're measuring longitude.
These lines aren't really drawn on the Earth, are they?
No, they're imaginary.
What do I want with imaginary lines? I need to find a real navigator.
You can use them as long as you know where the axes are on the Earth so that you can measure distances from those axes. To measure longitude, we'll measure distances from the prime meridian. We could do the measuring from any point, but we'll do it along the equator.
But the equator is a circle. How can you measure distances on a circle?
Whenever you measure anything, you need units to measure with. Since the equator is a circle, you need special units. We divide the circle into 360 equal parts, and we call each part a degree. So the units we'll use for measuring east and west from the prime meridian are called degrees of longitude. To make it simple, we'll just mark every 15th degree.
But there really is a degree of longitude for every degree around the circle?
That's right. Now we draw a line directly north and south through each mark and to both poles. Each of these lines is called a meridian of longitude. Each meridian is really half of a circle that goes all the way around the Earth. The other half is another meridian on the opposite side of the world. Do you know where you are now, north or south of the equator?
I'm about 500 miles south of the equator.
And I'll tell you what your longitude is. You're on the prime meridian. That's at exactly 0 degrees longitude.
Let's see. On the prime meridian, a little south of the equator. That means I'm about here. The note my navigator left says he's at the junction of 30 degrees west longitude and the equator. So to get to him, I must need to go west 30 degrees of longitude and then 500 miles north. But how do I know how far 30 degrees is? Is it a long way?
At the equator, the distance around the Earth is about 25,000 miles. Since there are 360 degrees around the Earth, we just divide 25,000 by 360. Each degree is about 69 miles.
Well, if 1 degree is 69 miles, 30 degrees must be 69 times 30, or about 2,070 miles. So that must be how far I need to go west. Terrific! My compass says west is that way. Here I go. My mileage counter says I went 2,070 miles west. So now I should be able to go straight north 500 miles and find my navigator. Bye! Something's wrong. My mileage counter said I went the right distance west, and then I went 500 miles north, but my navigator's not here. Nothing's here. What's going on?
There's something else you need to know. Each degree of longitude equals 69 miles only at the equator and nowhere else. As you get farther from the equator toward either pole, the distance between meridians of longitude gets smaller, until you get to a pole where meridians all come together.
Oh, I see. Because I was south of the equator instead of right on it, when I went 2,070 miles, I went past 30 degrees west longitude. So now I have to go all the way back to where I started?
No, let me help you this time. Now you're at 30 degrees west longitude on the equator. That's where your navigator said he was taken.
But he's not here. Now what? Oh, there's another note. They've taken me to 60 degrees east longitude. Hurry. My mother will be worried. East longitude? Does that mean 60 degrees east of me?
No. Let's take away half of the world so we can look at how meridians of longitude are numbered. There are 360 degrees of longitude, but they're not numbered 0 to 360. Starting at the prime meridian, which you know is 0 degrees, you can measure longitude either east or west. So the meridians on one half of the Earth are numbered from 0 to 180 degrees west.
And the meridians of longitude on the other half must be numbered 0 to 180 degrees east.
That's it. We've numbered only every 30 degrees on each side, but once again there is a meridian of longitude for every degree of the circle. 180 degrees longitude, like 0 degrees, isn't either east or west. In fact, the 180-degree line and the 0-degree line together make one huge circle that divides the world into two halves, the Western Hemisphere and the Eastern Hemisphere.
I think I can figure this out. I'm right here at 30 degrees west longitude, and I'm going to 60 degrees east longitude. And this time, I am on the equator. So I need to go 30 plus 60, or 90 degrees, times 69 miles for each degree, or 6,210 miles east. And I can see from my compass that east is that way. See you later. Oh no, still no navigator. They've taken him somewhere else. Now what? I'll never find him. Wait, there's a radio message. He said the bad guys left him somewhere on the equator. He didn't know where. All he knows is what time it is there.
Which is?
1:22 p.m. That's a different time than it is here. My clock says it's
6:22 p.m. where you are.
Right, but I don't care what time it is here or there. I want to know my navigator's longitude.
You can use the difference between his time and your time to find his longitude.
I can? How?
I'll show you. Let's think about what we mean when we say it's a particular time, noon, for instance, in a particular place. The sun rises in the east every day and gets higher and higher. Let's suppose you see it reach its highest point in the sky when it's as high as it's going to get. Then it's noon where you are. Let's say you're on this meridian. Then it would also be noon wherever you were on that meridian. And then the sun gets lower and lower in the sky as hours go by, and it gets later in the day until the sun finally sets. But you know it's not really the sun that's moving.
I know that. The Earth is really rotating toward the east, and we're turning with it. One complete rotation every 24 hours. That's one day.
So you move through one complete circle every 24 hours. How many degrees in a circle?
360. I remembered that.
Can you figure out how many degrees you move along that circle in 1 hour?
That's easy. You just divide 360, the number of degrees in a circle, by 24, the number of hours in a day. That's 15 degrees every hour.
Right. Now remember, we're supposing that the time where you are happens to be exactly noon. And remember, the Earth is turning toward the east at 15 degrees per hour. while the sun is at its highest point in the sky for you. For a person anywhere on a meridian 15 degrees to the east of you, the sun was at its highest point an hour ago.
So it must be 1 p.m. there, 1 hour later than it is where I am.
And for a person anywhere on a meridian 15 degrees to the west, the sun won't be at its highest point for an hour.
So it must be 11 a.m. there, 1 hour earlier than it is where I am. Oh, I see. There's 1 hour difference each 15 degrees.
Exactly. Let's see if you can use that idea. Now, you know it isn't really noon where you are. Your clock shows that it's actually 6:28.
And it's 1:28 where my navigator is. That's 5 hours earlier. So he must be exactly 5 times 15 degrees of longitude to the west, right?
Well, you're on the right track, but there's one other thing you need to know. It would be very confusing if people who are only small distances apart each had slightly different times of day. So to solve that problem, it was agreed that meridians every 15 degrees would be the centers of regions we call time zones. Every place in each time zone has the same time as the meridian that runs down its center.
I see. So my navigator must be 5 time zones west of my time zone. I'm here. 1, 2, 3, 4, 5. He must be somewhere in here. I know he's on the equator. So, if I just fly along the equator over that whole time zone, I've got to come to him, right?
You can't miss.
Finally! And there's my navigator.
And that's how you can use time to find the longitude of a place. You just count each time zone.
Excuse me?
Yes?
Can you do it the other way, too? Can you use longitude to find the time in a particular place?
To find the time?
He needs to call his mother, and he wants to make sure she's not asleep. Now, let's see. He says she lives on the equator, on an island at about 75 degrees east longitude. From where we are now, that's 1, 2, 3, 4, 5, 6 time zones to the east. So her time is 6 hours later than our time here. And our time is now 1:30 in the afternoon. So her time must be 1:30 plus 6 hours. So where she is, it's only 7:30 in the evening. She'd still be up. Go ahead and call.